All right, so those first three videos were really for students that were in class on Monday. The students that were in class on Friday, they had an opportunity to see those three arguments for sine, cosine, and e to the x. But I wanted the students that weren't there on Friday to have an opportunity to see those because it gives you some basis for where those shortcut rules come from. Now, today, what we're going to do together is we're going to look at a shortcut rule that helps us deal with the type of function that we're out of luck with now. And that's when we have a situation like this where we have the derivative of e to the x sine x. All right, our first instinct may be to go to e to the x cosine x, but that doesn't pan out when we start looking at the difference quotient and the limit definition. So first thing we're going to do is we're going to prove this rule, which says that the derivative of a product f of x times g of x equals f of x times g prime of x plus g of x times f prime of x. All right, so a lot of times to remember that, we'll say first d second, so first function derivative of second function, plus second d first. All right, second function times the derivative of the first function. And again, this comes out of the difference quotient. So we're going to start by writing that in our proof. So we're going to say the limit as w approaches x of f of w g of w minus f of x g of x all over w minus x. All right, now when we're in this should hopefully show us right here that in the top there's no way to factor this out so that we would have like an f of w minus f of x times a g of w minus g of x. We're missing some middle terms that we'd need to make that work. All right, so in the proof what we're going to do is we're going to go ahead and we're actually going to add something in, all right, that's not there, but then we're going to immediately take it back out. All right, it's a weird step, but it's something that really often comes in very, very handy in math problems, which is to put something in and then take it right back out. So what we're going to put in is we're going to put in an f of w g of x. All right, and then we're going to take that right back out with an f of w g of x. All right, so we've basically added a term and subtracted a term that were exactly the same. All right, and you'll see why in a second here. So this is all over w minus x. All right, so now what we're going to do is we're going to factor this by grouping. All right, so we're going to group the first two terms and the last two terms together. All right, and I'm going to go ahead and separate out the limit at each of those. So I have the limit as w approaches x. All right, and then I'm going to group these first two. All right, and I'm going to factor the f of w out. So f of w, and that leaves me with the g of w minus g of x, and that'll be over w minus x. All right, then I've got plus, and again, I'll break the limit here, so w goes to x. And on this one, I'm going to choose to factor the g of x out because it's the common factor. So I have g of x, and I'm left with f of w minus f of x all over w minus x. All right, so now we're going to go ahead and we're going to apply the limit a little bit. All right, so when I take a look at this one, when I think of this limit, the limit as w approaches x of f of w, all right, these are differentiable functions, so they have to be continuous. So we know that actually would just go to f of w. All right, and that's going to leave me with a limit as w approaches x of g of w minus g of x over w minus x. Plus, and on this one, w is what's changing, so that g of x out here in front is really like a constant. So I can bring that out in front of the limit. So I've got g of x, limit as w approaches x of f of w minus f of x over w minus x. All right, so when I look at this, what we want to notice is the structure that's coming up right here. All right, which should look familiar, and the structure that's coming up right over here, which should also look familiar. All right, so both of these give us the structure for a derivative. All right, the first one is the derivative of g of x, and the second is the derivative of f of x, because that is the definition of a derivative. So this, if I simplify it down, all right, and I apologize, as w goes to x, this would actually be f of x, all right, when I apply that limit. So we've got f of x, and then this is the derivative of g, so g prime of x, plus, and then here we've got g of x, and that limit goes to an f prime of x. All right, so we get that pattern that we expected, which is first d second plus second d first. All right, that is a formal proof for the product rule. So that is deductive, and it is without a shadow of a doubt. That proves that it definitely is true. All right, now in practice, this is pretty easy to use. All right, so we'll look at number 1 here, and it says use the product rule. All right, so first thing we have to identify is the two pieces that are multiplied together. All right, so the first one is going to be the 2x plus 3. All right, the second one is going to be this 5x minus 2. All right, so if I follow the rule would say my derivative, dy dx, all right, equals first function, so 2x plus 3, times the derivative of the second function, 5x minus 2. All right, plus the second function, 5x minus 2, times the derivative of the first function, the 2x plus 3. All right, now I intentionally did this in an extra step because that's really that's the line that takes us to what we need to do. All right, at this point there's still two verbs in there. So if I go in, this part says take the derivative of that. All right, and let me go to blue. All right, this part says take the derivative of this piece. All right, so it's first d second plus second d first. So now I'm going to go ahead and do those derivatives. So I've got dy dx equals, I've got a 2x plus 3 times the derivative of 5x minus 2, which we know is 5 from our power rule work, plus the 5x minus 2, derivative of 2x plus 3 is 2, so times 2. All right, so from a College Board perspective, that's a great answer for the derivative. A lot of times we will go ahead and clean it up, so dy dx. All right, if I distribute this in, I've got a 10x. If I distribute this in, I got another 10x, so I have a 20x. All right, then I've got 15 plus negative 4, which is 11. All right, so that derivative is a 20x plus 11. Now, once we do this, we could answer all the other questions we've answered before between find the equation of a tangent line, what is the slope at this point, what is the derivative. All of those are answerable from that. This is just a new technique for finding the derivative. So if I go on to example 2, it says take the derivative of cosine x sine x. So dy dx, all right, would be first, which is cosine x. D second, derivative of sine is cosine. So we have cosine x. Plus second, which is sine x. D first, and the derivative of cosine is negative sine. All right, so now if I clean that up a little bit, I've got cosine squared x minus sine squared x. And that would take me to a totally suitable answer. Now, you probably remember from your pre-calc days that if we were trying to solve something right now, to solve an equation, let's say, we might replace the sine squared x with a 1 minus cosine squared, so that we could get it all in cosine and solve an equation. At this point, we don't have to, though, because it's just asking us for the derivative. Now, we'll take a look at one more example of these right here. And it is find the equation of a line tangent to f of x equals e to the x sine x at pi over 2. All right, so this is a tangent line. So like always, we're going to go over here and say we need a slope and we need a point. All right, I think the point's always the easiest one to find. So that's our pi over 2, comma, and then we plug that in. So it's e to the pi over 2 times sine of pi over 2. All right, sine of pi over 2 is 1. So we're at pi over 2, comma, e to the pi over 2. All right, so our point's done. So if we come over here, we can think y minus e to the pi over 2 equals something times x minus pi over 2. All right, all I have to do now is I have to find the slope. All right, so the slope is given by the derivative. So f prime of x equals first e to the x. D second, the derivative of sine is cosine. All right, plus second, which was sine x. Derivative of the first, which was e to the x. All right, if I factor that e to the x out, I've got e to the x times cosine x plus sine x. And if I evaluate this at the pi over 2, because that's what we need, because we need f prime of pi over 2, I'm going to have e to the pi over 2 times cosine of pi over 2, right, plus sine of pi over 2, all right, which is going to be a 0 plus 1, all times e to the pi over 2. So we'll just end up with e to the pi over 2 for the slope. All right, so we'll bring that in, e to the pi over 2. All right, and that is our tangent line. All right, so again, those are kind of the mechanics of using a product rule. So it's first d second plus second d first. All right, and occasionally they'll ask you the same question, but they'll ask it from a table perspective like this one. So looking at this real quick, this said let the function f be defined as g of x times h of x. All right, so we should know now that that means f prime of x would have to be first g of x, d second h prime of x, plus second h of x, d first, which is g prime of x. All right, this asks us specifically what f prime of 0 was. So we're going to have g of 0 times h prime of 0 plus h of 0, g prime of 0. All right, and we're going to grab those out of the table because we have all these values for 0. So I've got g of 0 from the table is a -3. H prime is a 3. H is going to be a -1. And g prime would be a 5. So I've got -9 minus 5, which is a -14. All right, so we're looking at -14 for the answer of that. And again, that gives us from a table's perspective. So the first 3 problems were very analytic, and the last problem was based on a table. So that should take you through the first 2 homework sets in Khan with regard to product rule and product rule with tables. I hope that helps. I'll be back with a shorter video on quotient rule. It's another rule. We're not going to go through the full proof together. Thanks. Bye.